Welcome to rhombi and squares. So first thing we need to talk about the definition of both a rhombus and a square. So let's start with a rhombus. It is a parallelogram, and it's a parallelogram that has four congruent sides. So a rhombus is kind of like a slanted square, so all the four sides are congruent. A square basically is a rectangle and a rhombus together. So it again is a parallelogram first. So it has to have all the properties of a parallelogram that has four congruent sides and four right angles. So we all know that a square looks like this, but we also know all sides are congruent and all of these corner angles are right angles. So that is your definition of a square. So now what are some properties we know about these? It always has to do with the diagonals. So first thing, we see that in a rhombus, your diagonals are perpendicular. So it's always a right angle right here in the middle, which then in turn makes all of these triangles in the middle right triangles. So then that means you could possibly use some SOHCAHTOA in there if you had to. Definitely Pythagorean theorem you'll probably see. And then the other thing that we know about the diagonals is they bisect the opposite angles. So what that means is angle 5 and 6 here are the same measure, and angle 7 and 8 are the same measure. So basically all of these blue angles here are the same measure, and same with the red ones. So these two angles, 3 and 4, are the same, and 1 and 2 are the same, which in turn makes all these red angles the same. So all the angles across from each other are going to be congruent. Now if you look at these diagonals, these, yes, actually would be lines of symmetry like we talked about before, because this would cut the rhombus in half, so these triangles are the same as these. Or this would also cut the rhombus in half, so it would be here and here would be also the same. So knowing that may also help you with these properties. So here we have the diagonals of the rhombus intersect at V, and we are now looking at, this is supposed to be the measure of angle WZX is 39.5. So this angle here is 39.5. And we want to find the measure of angle ZYX. So ZYX is this whole angle here. So from what we know about diagonals in a rhombus, we know that the diagonals that are in the same corner, or I'm sorry, the angles that are in the same corner are the exact same measure. So because that one's 39.5, this one is also 39.5. Now I can use the property that I know that this is a right angle here, so it's a right triangle. So I can take the 39.5 and subtract from 90, and that's going to give me the measure of that other small angle there, which would be 50.5. So I know this angle here is 50.5, which would make this angle here 50.5. And then if I add those two together, you get 101. Now that's one way to figure it out. Or I would know, since both of these two here are 39.5, that would add together to give me 79. And then knowing that it's a parallelogram, this angle here and this angle here to add to equal 180. So I could do 180 minus 79, and that would also give me 101. So two different ways to find the answer to the same problem. Next example here has to do with writing equations. So it tells me that Wx is 8x minus 5, and then Wz is 6x plus 3. Being that I know this is a rhombus, those are the sides. I know all four sides are congruent, so I can write the equation 8x minus 5 equals 6x plus 3. Remember, variables first, so I want to subtract the 6x from both sides, which would then make this a 2x minus 5 equals 3. Then I want to add the 5 to both sides, which would make it a 2x equals 8. Then divide by the 2, which would give me x equals 4. So my x in this problem would be 4. One more example I want to take a look at has to do with squares. So it says Hector's measuring the boundary of a new garden. He wants the garden to be square. He has set each of the corner stakes 6 feet apart. But just knowing that each of the sides here are 6 feet apart, here, and I would assume here and here, does not give me enough information to tell me it's a square. If I know all 4 sides are the same, that only tells me that it's a rhombus. So what they're wanting us to talk about is the diagonals. If you measure from here to here and here to here, we have to see that your diagonals are perpendicular. So in a square, you have to know all the properties of a rectangle and a parallelogram, or not a parallelogram, a rhombus, in order for this to work. So for a square, that has to be perpendicular in the middle. Now, going on talking about a square, because you have a couple problems that talk about angles in a square. Hopefully you noticed in the exercise the other day, if this is a rhombus and a rectangle together, a rhombus means that the angles here in the middle are all right angles. Because it's a rectangle, I know the diagonals are all congruent. So all of these are the same. Which then, in a square, makes it an isosceles right triangle. So a square has all kinds of things congruent. So because those measures are the same, that means each of these angles here, all the small angles, are always going to be 45. It doesn't measure, or it doesn't matter the size of the square, these angles are always going to be 45 all the way around. Which then, if you remember your special right triangles, that makes this a 45, 45, 90 right triangle. So all I really needed to know was the measure of this, and I could find the length of the diagonal. I believe you do have a problem where you could use Pythagorean theorem to find the length of this side. So it is a right triangle, still sticking to our Pythagorean theorem to find lengths.